Right, one interesting thing that we might have observed with solving log equations or exponential equations is we could log both sides and we could select a base, right? Now, using that idea, it can help us to change the base of a logarithm if we wanted to, right? So if we had a log with base b, but we wanted to change that to base c, right, for whatever reason, right, it might help us solve the equation more effectively, right? We're going to look at the rule that we use to do that. Well, it might be interesting to know that this is how logs with bases other than 10 were calculated before calculators included a specific button. Okay, so in the olden days, the log button where you can input the actual base didn't exist. The only buttons you had on the calculator were the log button, which was to base 10, and the natural button, which is log to base e, which we'll learn about later on. So let's see where we get this change of rule from. Okay, so if we consider some log, okay, it's log base a of, base b, and the value is a, and x is the thing we're trying to find, okay? It's the exponent, right? We know we can rewrite this in a different way, and we can rewrite this as, we keep the base the same, right? We have the exponent and the value. Okay, so this is where our log came from, because we were trying to solve the exponent, right? And from our log equation, we've just changed it back to exponential. So instead of using where we identify the exponent, the base, and the value and change it that way, what we're going to do is we're going to use that method where we log both sides. Okay, and the nice thing is I can choose whatever base I want because it doesn't matter. So here we're going to choose log, and we're going to log to base c on both sides. Right, and from here the rule is quite simple. Using the power rule, we can bring the x down to the front, and the other side, nothing magical is happening there. And we want to solve for x again, so x is equal to log of base c of a over log base c of b, right? So if we look back to the original equation where x was equal to log b base a, so x was equal to log base b of a, this can now be rewritten as log of any base c of a over log of base c any base of b, right? So it's interesting to note where the two things have gone. The value has stayed at the top, and the base has gone down to the bottom, right? And this also brings an interesting observation. If we are dividing logs with the same base, they can be simplified where the bottom value becomes the new base and the top value becomes the new value. Okay, so let's look at some examples of why we'd want to change base. So the most simple reason would be if we didn't have a button on our calculator that had log base 2, right, or we couldn't select the base, and the only button we had available to us was the log button, which is to base 10. Okay, so remember, if we just write log, it's implied base 10. So here we have log base 2 of 7, and we want to change this into something that is log base 10. Okay, so using our rule, we can see that we can create any base we want. The value is going to go to the top, and the old base is going to go to the bottom, right? And so what we could very quickly do is we could put into our calculators log 7 divide by log 2, and we'd end up with 2.807, etc., which we can round to 2.81, which is 3 significant figures. Okay, so essentially one of the reasons we needed to change the base a long time ago was because we didn't have this button. Okay, we didn't have the button where you could specify the base. And so we had to convert everything into base 10. Okay, let's have another look, or a look at another problem where we might want to change the base. Okay, so here we have a log equation where we've got logs on both sides already, but the bases are different. Okay, now we could convert this back into exponential, where we say this is the base and this is the value and this is the exponent, but then our exponent now is another log, and so it becomes tedious. So what we can do is we can just change everything into the same base. So what I'm going to do is I'm going to keep the same base on the left hand side, and I'm going to change the base on the right hand side. Okay, so this is log base 9, and I want to change it into log base 3. So to change this into log base 3, I'm going to write log at the top, log at the bottom. I'm going to select the base. I want to make the base the same as the left-hand side, so we're going to choose base 3. Right, the value at the top is what goes as the value on the top one, and the old base becomes the value at the bottom. Okay, now this is nice because this is basically saying what do I raise 3 by to get 9, and the answer is 2. So we can already simplify that as log base 3x equal to log base 3 of x plus 6 all over 2. Right, now I can multiply both sides by 2, and I'll get 2 log base 3x equal to log base 3 of x plus 6. Using the power rule, or reversing the power rule, I can bring that number back to the exponent. And now I have logs on both sides with the same base, which means I can equate the values. Okay, so just like we equate exponents, we can equate values if we have the same base. So x squared must be equal to x plus 6. And this is just a standard quadratic, right? So we can factorize. This is going to be x minus 3, x plus 2. And so x can be equal to 3, or x can be equal to minus 2. Now, the one thing we have to remember is this is a logarithmic equation, so we have to check all of our values. So let's check. Okay, so if x was equal to 3, let's consider the left-hand side of the equation. We'd have log 3 of 3, which we know is just 1. Okay, on the right-hand side, we would have log base 9 of 3 plus 6, which we can already see is just going to be log base 9 of 9, which is again equal to 1. And so this solution satisfies the equation. Okay, right, let's check if x is equal to minus 2. We'll check the left-hand side first. So we have log base 3 of minus 2, and immediately we have a problem because we cannot have a value that is negative or less than 0. And so x cannot equal negative 2. All right, and so this is not a solution. So the only solution, therefore, x can only be equal to 3. By doing plenty of examples, you will pick up on when it's a good idea to change the base of one or both sides of the equation, right? But also the most important thing is to remember that these are logarithmic equations, and you always need to check your solutions are valid.